We should be able to just go through these. I want to get through these 6 examples. I tried to kind of pick out some examples that are a little bit different. Each one's got a slight difference in them, for the mere fact of having at least 4 or 5 example problems that you can look at, so that you can compare to those that you're going to see in your homework this evening. As we work with literal equations, guys, what my hope is that we understand is that obviously you're going to have, if we go back up to those formulas up there, we're going to have a series of variables. You might have 2 variables, you might have 3, you might have 4, whatever, okay? But whatever variable we are trying to solve for, we're going to let it be we're going to treat it just like a variable. Everything else you treat like a number, okay? And to be honest with you, even the one that we choose to solve for, we're still treating it like a number, okay? But we just don't know what the number is. So we're using these symbols to represent some unknown numbers, okay? And if we can remember that, if we get stuck, I'm going to ask us to kind of think back or draw conclusions to the idea, what would you do in this case if this letter was a number? And then figure out what you would do if it was a number, and then do that same exact process with the variable, okay? And we'll kind of talk through some specific examples of that. Right now what I want to work on is this middle one, the A equals BXT plus C, okay? We want to solve for X, so we're going to get X all by itself, okay? So I'm going to highlight the term that X is in. Okay? And now the idea is this. If the X is the variable, that means everything else up there is supposed to be some number. We just don't know what those numbers are. Okay? So let's say like if the C, instead of being C, was 5. Okay? And let's say if this B, instead of being B, let's say it was 3. And let's say if this T was 2. So you'd have 3 times X times 2, right? Would you write that as 6X? And let's say if this A was, 20. If you had that situation, what would you do first? Lindsay? Subtract 5. Okay, so let's think about this. If I'm going to subtract 5, let's think about what 5 really was. 5 was really C, wasn't it? So let's subtract C. Okay? And we'll come over here and subtract C. Now, I don't know, like we said, I let that be 20, but because I don't know what C is, I really can't do the subtraction. Like if C was like 5, it'd be 20 minus 5, right? It'd be 15. I can actually get that 15. I can do the subtraction. But I don't know what C is in this case. So it'd be 20 minus C, right? But I also don't really know if that's 20. That's A, right? So I'm going to write that as A minus C. Okay? And now on this right-hand side, remember, we would have like 6X, right? That's kind of what I've used here. But what is that 6? Or how would I solve for this? How would I get that X by itself? I'd do what? Divide by 6. But remember what we did. That 6 was actually B times T, right? Does that make sense, everybody? So at this stage, I don't have 6X. I have B times T times X. That's the same thing as that. So if you can kind of visualize or think through your head, now we actually wrote down numbers, but if you can justify in your mind that everything except for X we're going to treat like a number, and then go through our process of solving the equation for that variable that we've chosen, it's the same thing that we did in 2.3 and 2.4. Okay? What would you do? So we said this was 6, you would divide by 6, but because now it's BT, we're going to divide by BT. So what that allows me to do is really whatever B and T are, maybe it is 6 when I multiply them together, and I'll divide by 6. But what if B was 2 and T was 4? Now I would divide by 8, right? So it's allowing that coefficient to kind of change based off of what B and T are. So now those would cancel, right? Leaving you just X. And on the right-hand side, I guess it'd be the left-hand side, you have A minus C all over BT. And that would be my final answer. That is solving that original equation for X. Okay? Solving that original equation for X. I want to check this. Okay? And I don't know if I showed you guys yesterday checking these by hand. I'm actually going to use Desmos because I think you guys are going to appreciate this a little bit more. It's a little bit easier. Okay? But we got to kind of have an understanding of what we're trying to do here. When you check these, you are going to look at the item that is isolated in the beginning. So A is isolated in the beginning, right? We're going to leave that alone. We're not going to do anything with A. And we're going to choose values for B, X, T, and C. Does that make sense? Okay? So, and I don't care what values you use. My suggestion, though, is stay away from 0 and 1. Stay away from negative numbers. And try not to repeat values. So I don't want B to be 2, X to be 2, T to be 2, C to be 2. Does that make sense? Okay. I want them to be different. But if I use that idea, so somebody give me a value for B. Say it louder. 7's what I heard. What about X? 2. What about T? 4. And C. All right, so we got those. And that's all you've got to do in Desmos, okay, is you just hit the letter that you want, capital or lowercase, equals, and then the number. So now what Desmos does is it understands whenever I'm going to type B again, it's going to use 7. Whenever I'm going to type X again, it's going to use 2. Does that make sense? So let's look at our formula that we started with. It said A equals B X T plus C. Does that make sense? Okay. Now, how does that help me? And I don't know what's going on with my projector. Came in this morning and it's making its way onto the wall over there. I get 62 there, right? Now, here's the thing. If I have done this correctly, if we have solved that equation for X correctly, I should now be able to take A, subtract C from it, divide all of that by BT, and it should give me what X is. Well, what did we say X was? X was 2, right? So I should be able to type in the formula that we got at the end and see if it spits back the 2 that we declared to be X early on. So if I say A minus C divided by BT, the reason I like Desmos is because it writes it or types it in like I would write it by hand. Okay, so I can guarantee myself that that typed in my calculator correctly. Does that equal X? That makes sense, everybody? So this is going to get this 2 to go right, but that's what we solved for, right? We said A minus C over BT is equal to X. Well, X was, as specific values, we said X was 2, and now we're getting 2 down there. So that's the link between us doing this correctly. Does that make sense? Okay. If I want to, give me another B value.
4.
Okay. Give me another X value. Okay. Give me another T value.
92.
Okay. Give me a C value.
60.
Okay. Now, we see I chose random value. Now, if I'm doing this on my own, I probably don't want to choose values that big. When I use Desmos, does it still give me what X was? X we said was 274, right? No matter what number you plug in there, guys, you're going to get back, because A minus C over BT is solved for X. You're going to get back that number that you predefined earlier as X. Does that kind of make sense? I think that's a great tool for being able to check these literal equations. And that's going to be something, guys, that really comes into play down the road. I think it's chapter 4 or 5. We start graphing equations. That this literal equation process is going to be something that we want to come back to and discuss and be able to do this and then be able to use that checking process. All right, so let's see here. Anything similar? This one. Let's actually do this one first. Huh? You've already asked me if I have Band-Aids. I don't have Band-Aids. All right, so I've got mx plus nx equals p. And I want to solve for x. It's a little bit different than the last one. How many times did x show up the last time? Once. How many times do we see it here? Twice. We've got an issue. That is a big problem for us. But think about this. M and N and P are just numbers, correct? So if they're just numbers, give me a number for M. 4? Give me a number for N. And I don't care what P is. But what would you do if it was 4x plus 7x?
11.
That gives you 11x. How'd you get 11? Okay, you took, so this is the idea. You took the 4 and the 7, added those together and got my 11, and then multiplied that by the x, right? Okay. Well, give me another number for, well, let's do this. Let's say this was 14. What would you get there? 14 plus 7 would be 21, right? Okay. Wouldn't this be 31? So you're always adding, no matter what these things are, you're adding together, right? Well, what if they're M and N? Wouldn't that look like this? Does that make sense? Getting the 7 plus the 4, or the 14 plus the 7, or the 14 plus the 17, you're just adding those numbers out front. And in our literal equation, those numbers are represented by the symbols M and N. Okay. How can I know that I'm right? How can I know that that's okay to rewrite that way? If you multiplied that through using distributive property, does that give you mx plus nx?
Yeah.
So we know that that's an equivalent format of what we started with. Okay, so that's good. Now, m plus n, when those are values, that would be a coefficient for x, right? So if it was, where do we start with? 11x. Like 11x equals some number p. What would you do to both sides to solve for x? You would divide by 11, right? So remember, this is just a number. So if it was 11x equals, let's say, 33, you would divide both sides by 11, right? If it was 12x equals 33, what are you going to divide both sides by? 12. Okay? If it was r times x, what would you divide both sides by? R. Now, if it's m plus n times x, what are you going to divide both sides by? M plus n. Whatever that's a coefficient, right? That's playing the rule of our coefficient. So divide both sides by that. So divide this side by m plus n. They're going to cancel. Come over here, divide by m plus n. So when I cancel on the left, you're left with just x, right? And now I get p over m plus n. And now I've solved for x. But the whole kind of game here that I want us to play is that do we recognize the relationship between what we do with numbers and what we can do within symbols that represent numbers? Do the same thing, right? Let's check it. So we need an m. We want m to be n, x. I heard 8 first. All right, so then I'm gonna go. Now this is the only thing about Desmos is if I put the equals p at the end, it's not gonna know what to do. So I got to use the symmetric property and put p equals that way. Does that make sense? Okay. When you define variables in Desmos, it needs the variable first, equal sign, and then what you're going to define it as. So I get that. So it should be 56, right? So now the idea is I should be able to take P divided by M plus N, and it should give me back X. That's what we solved for, right? We solved for X.
Yep.
Does it give me back the X that we chose? Yep. Okay. And it will give me that no matter what you chose. Just stay away from 0. This is the reason I would stay away from 0. If I let that be 0 and let that, we'll keep that 8, but let's let this be 0. That'd be 8 divided by 0 plus 0, right? Can I take 8 and divide by 0? No. So that's why it gives me that undefined. So in situations like this, just to avoid that ever happening, I would make sure that I try to stay away from using variable values of 0. But you can use negatives if you want. Okay. But if you want to stay away from negatives, I would highly suggest that. So let's look at this one. Okay. S equals C plus X times C. It looks very similar to the last one. Okay. The last one said something like this, where it was P equals MX plus NX, right? Where the X was the thing that repeated. What's the thing that repeats here? C. Okay, so they're very similar. And I would use the same approach that I just used if I was solving for C, but what am I trying to solve for here? I'm going to solve for X. So even though the original problem looks similar to what we've already seen, we still have to pay attention to what we're solving for. So I'm solving for that. So that I put this on here to make sure that we understand that the structures can be the same, but they ask you to solve for different types of variables or in different positions. Maybe the route that you get or that you take will be different. Okay? So if I want to isolate that, I want to get that by itself, what would you do first? Subtract. See, think about this. S is a number, right? So let's say it's 10. C is a number, right? Give me a number for C. 4. So now you have, X is what we're solving for. We're going to leave that as a variable. But it's X times C, right? What was C? We let C be 4, right? Now, if you had this equation, you would subtract 4 from both sides, right? Okay. Well, 4 was the C. So let's subtract C from both sides.
Okay. So minus C.
Oops, too far. All right, so you're going to subtract C from both sides. So minus C. Now, I would have S minus C, right? Does that make sense? I can't really do that subtraction. I don't know what S is, and I don't know what C is, so I don't know what their total is, right? And then I have X times C. Now, remember, you told me C earlier was 4, right? Would you rather write that as X times 4 that way, or 4 times X? Okay, so if you want, it doesn't really matter, but if you want to write this as CX, a lot of people prefer that. Now what would you do, Lindsay? Divide both sides by C. That'll give me 1X. Come over here, divide by C. So S minus C over C is equal to X. Well, there's. So here's the question, guys. We want to know: can I just rewrite this as S because that C and that C cancel? And that's the question. And here's how I answer that question. If those are going to cancel, then I should be able to take S, which is a number. Give me a number. 4. Minus C. Give me a number for C. 6. Over 6. So if I do this math correctly, that should give me, if we say if they cancel, it should give me 4, right?
Yeah.
But if we go through our order of operations that say the division bar operates as parentheses, we have to do that first, right? I get -2 over 6, and that turns into -1/3, which is not equal to the 4 that we would get if they cancel, right? So because those two things are not equal, that tells me that canceling that would not work. If it was S times C over C, then they automatically cancel. Okay, but when you have a fraction and there's a sum or a difference in either the top or the bottom, things are going to cancel 1 to 1 like that. Good question. And guys, that's an example right there. It's another. It's not what we're focusing on, but it's being able to realize that variables are just symbols for numbers, right? If I know what to do with the numbers, then it tells me what I can do with the variables. All right. So go to the side and make just a generic question, okay? And see if answering that generic question maybe sheds light on what you can do here algebraically. All right, this one I cut and pasted and I messed it up. So get rid of that X, because it's the same question. And I want to put C there. Because it's completely different in regards to what I'm solving for. Same exact formula, it's a completely different procedure. Okay? Now, solving for C. So now, this is kind of like this one here, where we had X's on both these here, right? And we're solving for X. Here, we got C's on both of these, and we're solving for C. Okay? Now, let's do something like this. Give me a value for C. So we would have, I'm sorry, I messed that up. Give me a value for X. 9 still, okay. So what we have here is S equals C plus, if you said X was 9, this would be 9C. How many C's do you really have?
2. That's 2. I mean 3. I mean 2.
You have 10. Because this is 9 of them, and then this is 1 of them, right? Give me another number for X. Okay, so this would look like this. So how many C's do you have there? 7 C's. Okay? Because you're taking the 1 that is here and adding whatever that is there, right? Well, so you're getting 1 plus 6 times C. If this is 6, you get 7. If this is 7, you get 8. If this is 100, you get 101, right? Well, what if it's X?
Then you get 1X.
Careful.
Get 2X.
Careful. What were we doing with these coefficients? You said 1. When you say 1x, you're telling me you multiplied them.
Oh, 1 plus.
We were adding them, right? So 1 plus x is what we're getting here times our c. Does that make sense to everybody?
Yeah.
How can I check? How can I see if that is true?
You distribute.
Distribute and see if I get back to c plus xc.
You do.
Okay, I do. So that's good. So that's okay. Now, if you recognize that process, it went from a line that had 2 C's in it, right? And that was the issue. That was the problem for us. Now we have a line of work that only has 1 C, and that's good. Okay, it only has 1 C, but I didn't lose any meaning. I still have the same amount of C's in that line as I do in that line. So now, how do I solve for C? How do I get the C by itself?
Distribute.
Well, if I distribute, it's going to get me back to where I was.
Oh, yeah. You got.
By what?
1 plus
1 plus x. Okay? Because remember, this is just a number. X is a number, right? So if x is 9, this is 10c. So you would divide both sides by 10. So I'm going to divide by that. Come over here. Divide by the same thing. And now I get s over 1 plus x is equal to c. Huh?
You do that little dump?
Uh-huh. Did you rattle your head?
No, but it was Santa Claus.
Oh, okay.
Okay, do you like Crocs?
No.
Why?
They're hideous.
I got Crocs first.
What?
And on my other shoe.
right.
125.
Excuse me?
Use that number.
All right, so let's do this one. This one's different than anything we've done so far because now we see our equation having a fraction in it, right? When you have fractions, you want to get rid of fractions as soon as possible, right? Remember, y is just a number here. Y is just a number. So if I had like x plus 2, give me a number for y.
1,689.
I like 7, thank you. Okay. What would you multiply both sides by to make this easier, to make that 7 disappear?
1/7.
Well, careful. If I multiply by 1/7,
7 over 1.
okay, I'm going to multiply by 7 over 1 instead. Okay? 7 over 1. And now that 7 is going to cancel with that one, leaving me just x plus 2, right? And on the right-hand side, I'll multiply by 7 again. It gives me 14, correct? Okay, well, what if that 7 was 8? What would you multiply both sides by? 8 over 1. What if that was 81? What would you multiply both sides by? 81, right? Well, okay, so the fact of me saying it was 7 or 8 or 81 is saying that I don't care what it is. It could be anything like y. And if it is y, what are you going to multiply both sides by? Y. Okay, so I'm going to multiply this by y, and I'm going to multiply that by y. So just like it was 7 or 8 or 81, those numbers are going to cancel. You're left with x plus 2 is equal to 2y. Now you'd be left with one more step to do what to solve for x? How do I get that by itself? Subtract 2. So x equals 2y minus 2. Does that make sense? Okay. Let's approach this, and instead of solving for x, let's solve it for y.
Okay. I can do it.
So why don't you guys take a minute and do it on your own. Solve for y. Get y all by itself. When you have a fraction, what do you try to do first? Multiply by that common denominator, right? LCD, you got to get that out of there. So the LCD here, still y, right? Multiply both sides by y. It gives me x plus 2 equals 2y. Was that the same step as before?
Yep.
Yeah. But now what are we trying to get by itself?
The y.
The y. So what do I need to do now?
Minus the y.
Okay, let's do what you said. You would have this then. Did that get the y all by itself?
No.
No.
Minus 2.
I want to divide by 2.
What? Where?
Because remember, when we say we want to get the y by itself, we want this to become a 1y, right? Huh? I'm going to divide this by 2, and those are going to cancel, right? If I divided the right-hand side by 2, I have to divide the left-hand side by 2. So you get x plus 2 over 2 is equal to 1y. That's fine. Questions on this so far? To be honest with you guys, I think this is one of the harder things that we will do.
Wait, the whole year?
I mean, for a while. Probably not the whole year, but for a good chunk of the year, I think it's hard to think about because you got so many variables up there, but at the same time, we got to think, well, those variables are really just numbers. and it's abstract. I think if there's numbers in there, it's less abstract, okay, and easier to think about. Let's do this one, okay. A equals G plus F over 2 times H. Couple things you can do. What do you want to do? Divide by 2? Multiply by 2?
No,
If I multiply by 2, we would have, so this is I'm going to come to the side real quick, 2 over 1. This would be G plus F over 2, and this would be H times over 1, right? If I multiplied by 2, that's going to cancel with that one. That's perfectly fine, right? So multiply by 2 to that side, I get 2A equals now G plus F, and I've got my H. I like that. I like multiplying there by 2. That makes sense, I think. Now, remember what we want to get by itself. We want to get that G by itself, right? Why would I divide by 2? Okay, every problem is a little bit different. Remember what you're trying to... I want to try to get G by itself here. Okay, so if I subtracted F... here's the idea. If I subtract F... Trying to think of a... So let's say A is like 5. I don't know if this is going to prove my point or not. And then let's say G was 3. Let's say F was 2. And let's say H is just H. So here you'd actually have 5 H's, right? If I just subtract 2, do you see how that's actually 2 H's that we'd be worried about and not just the value 2? So I can't, because of this set of parentheses, I can't just start plucking things away from there. What we have to do is kind of work our way from the outside in here. And there's 2 things you can do. What does a set of parentheses with a sum inside of it? Okay, you can distribute. That is one option. I like that option because now it turns it into... Well, it looks a lot like the problems that we did earlier, right? Okay. And if I want to, remember, I want to try to get the G by itself, correct? Okay. So what could I do here now?
Divide.
All right, careful. If I'm trying to get the G by itself, I need to get that term right there by itself. Well, don't I need to get rid of this first before I divide?
Minus that.
So 2A minus FH equals now GH, right? Now what would I do to solve for? Now I divide both sides by H. And that's going to give me 2A minus FH over H equals G. Okay? Now, let's see if this all pans out. Let's grab our calculator. Especially on these questions when I think this is kind of a messy problem, right? So I think it's when you do all this work, you might as well take the extra 30 seconds and see if your work was right. So give me a number for G. Give me a number for H. Give me a number for F.
5.
Okay. So now I'm going to say capital A is equal to, what do we have? F plus G. Now this is the reason I like Desmos, is because I can type this just like I would have written it by hand. And then I got my H over here, right? Does that make sense? That should look exactly like what we started with. G plus F. All right. Doesn't matter. Addition is commutative. But G plus F over 2 Okay, and then divide or multiply the whole thing by h. And if you want to, you can come back and actually delete those parentheses out. But 49.5, right? So now let's type in what we came up with for g. We said it was 2a minus fh, all of that divided by h. Does that give me the g that we started with? Spits back 6, which was the g that we started with, right? Okay. Let's do this a different way. You guys told me to multiply both sides by 2 right away. That's fine. So let's continue with that route. If I go 2a is equal to g plus f times h that way. Can I divide both sides by h right away instead of distributing? Does that make sense? So I have 2a over h is now equal to g plus f. Now what can I do to solve for g? Subtract f, right? So I get 2a over h minus f is equal to g. Now, here's my question. Does that look different than that?
Yeah.
Looks different, right?
Yeah.
Okay. But,
Same thing.
why?
Because they wanted them to remind me of the same fraction.
If we have something like this, if I have 1 over 3 minus 2 over 3, can we write that as 1 minus 2 over 3? Can I do that?
Yeah.
Is that 3 a common denominator? So if I started with something like this, can I separate it into something like that? Isn't this kind of what I've got going on right here? So let's separate that over h. 2a over h minus fh over h. Does that make sense to everybody? What do you see here with these h's? That's where they can cancel because the product here. If they cancel, does that leave me 2a over h minus f? Is that the same thing that we had there in pink? Okay. Those little things of knowing when to cancel, why to cancel, being able to determine whether one representation of 2a minus fh all over h is the same as 2a over h minus f. Those connections, guys, is what we're really interested in algebra and recognizing that ability to kind of jump back and forth between the two formats. And you'll find out as you get into Algebra 2 and beyond, or Integrated 2 and beyond, you're going to find out how important that process is. Okay? Remember, what algebra is it's like if you're in sports, you usually weightlift and condition and that kind of stuff, right? So that you can go perform somewhere else in a more kind of athletic situation, like a competition, like a game or a match or something, right? Okay? That's what Algebra 1 and Algebra 2 are kind of like. They are conditioning you. They're getting you that practice on being able to eventually work inside a course that you use this stuff to actually do maybe a little bit more authentic type problems, more real world like problems. Does that make sense? So we're building those skills, and this ends up being a very, very fundamental skill for that later set of courses and concepts. I'm going to stop there. You guys got about 7 minutes here. If you want to open up that assignment 2.5, be due tomorrow. It's 10 questions. Again, I think this can be a tedious process. So I don't want to bombard you with 25 questions. So work on those. We're going to talk about those tomorrow. They're going to be due tomorrow evening. So if there's any that you work through 2 times, 3 times, and you're still getting them wrong, save yourself at least one example so that you can ask about that tomorrow. We work through it and you get that point for it before it's graded tomorrow night.